People missed it. So you do in the parentheses first. -6 squared. What would that be? It's not positive. That's the trick. Why not?
I don't know.
Because the exponent is not on the outside. When it's on the inside, it's only going to square the 6, not the negative. This is where we talked about the difference between this and this. Okay, this one is a positive 36. This one is a negative 36. Because you're not squaring the whole thing, you're just squaring the 6. So it actually becomes 12 minus 36 divided by 3. Two negatives become a positive. Then you do division first.
Why do you change the two negatives to a positive before you do the division? Turns into addition of the
Because this is really multiplication. A negative and a negative is multiplication, so you turn that into a positive before you do anything else. And even if you did the division, that would be okay. It would be -36 divided by 3. It would be a -12 with a negative here. And the negative and the negative become a positive. So it kind of doesn't matter which order. -6 and the answer is 8. Does that make sense now that you see that it's a -36? All right. Other questions? No other questions?
What about 15?
15. Okay. In this problem, we're subtracting fractions, and we have to get a common denominator. But before we do, what would be the first step? Make the second one an improper fraction. It would be -5/8 minus a minus 55/12. And how I got that is 12 times 4 is 48 plus 7, 55. Negative and a negative become a positive. Whenever you see two negatives together, you turn them into a positive. Now I get a common denominator of 24. Which makes this -15, and what does it make this one? 110. So -15 plus 110 is 95/24 would be one answer, or you could rewrite it as a mixed number, 23/24.
And then, how again did you get the 55/12?
Okay, right here, I turned the mixed number into an improper fraction. So I did 12 times 4 plus 7.
Okay.
There was somebody on the test, the only reason they missed the problem is they were doing this wrong. They were turning in mixed numbers to impropers wrong. So I'm not sure who it was, look at your paper, but that was the only reason you missed several problems. So make sure you know how to go from here to here. I tried to make notes on ones you missed. If you see any discrepancies in your grading, let me know. But I'm going to collect them for right now. You guys get these back at the end of the semester.
I don't ever want to come again.
Never again?
Sorry.
Oh, do you have a question?
No.
Oh, okay.
Okay. Oh, that's horrible.
The average of the test is
3.7 grade point, and math is my worst subject, and I live in the math lab, and I'll end up pulling these. I know I will. I'm going to do it.
What they were asked to do.
I don't mind to see, but I'll pull. I'm going to try my hardest. I do.
So because you did the steps correctly,
It might change my
because I can just
look like you're as good as you thought you were.
but they were really wonderful.
And I would have to say, please don't kick me out. They need you.
You knew how to solve it.
And they would say, too bad.
College career. Did I get you guys right?
Yeah. I dropped all my classes and picked up
Oh, yeah.
Nope.
No.
Okay, I'll raise
The reason we don't give them back is so other students don't get this test before they take it. There's people that take these late.
Okay.
Thank you. And if you'd like more time in class to look at it,
Okay.
I'd be happy to give it back to
What
you.
was our class average?
68 is the class average.
All right.
And the median was 72. So the
Okay.
median is the middle number, and the average is the average.
I don't feel so bad.
Okay. All right, so let's start chapter 2. Are you guys done with the Comcast thing? Can I erase it? Okay, chapter 2 is going to be all about solving linear equations and inequalities. So this is where we solve for x, okay? We learn how to solve for x. The first section, 2.1, is going to talk about combining like terms. So before we can combine a like term, we have to figure out what a term means. First, there's things called variables. And variables are just letters used in math to represent numbers. Okay, so this is like X, Y, Z, whatever letter they put in there that is supposed to represent a number. That's called a variable. An expression is just a collection of numbers variables and operations. For example, 4 plus x. Numbers, variables, and some kind of operation. Anytime you put those things together, it's an expression. What can you say about an expression versus an equation? Does anybody know? No answer, correct. You don't solve for anything. And so there's not a what sign. There's not an equal sign. Very good. Okay. So several parts of an expression are called terms. Parts of an expression. So how many terms would this expression have? 3. There are 3 terms. Every time it's broken up by an operation, that's a new term. So this one has 3 terms. Last definition is called a numerical coefficient. And it's just the numerical part of a term. So in my example up here, what would be my numerical coefficients? Be -2 and 3. Those are the numerical coefficients to those 2 variables. Okay, let's look at 3 different terms and find the numerical coefficient. What's the numerical coefficient of 5x? 5. What's the numerical coefficient to this one? 4. Just 4, because if you distributed this, it'd be 4x minus 12. So the only coefficient with a variable would be the 4. What's the numerical coefficient of this one? 2/3. Because this x is on the top, but another way to write 2x over 3 is 2/3 x. So the numerical coefficient is 2/3. Okay, very good. What do you think the numerical coefficient of this term is? Somebody said it, 1. The numerical coefficient is just 1. So if there's no number in front of a variable, you can assume it's 1. What do you call a term that has no variable? It's a constant. So a number by itself is called a constant. In this expression, the -4 is the constant. So if there's a number without a variable, just a number by itself, it is called a constant. Okay, now we're going to talk about what like terms are. Like term is a term with the same variable with the same exponent. Constants are like terms. And this sounds complicated, but it's not. When I show you some examples, this is going to be real easy to figure out. Here are some examples of like terms. 3x and -4x. Those are like terms. 5 and -6 are like terms. 3 times x plus 1 and 2 times x plus 1 are also like terms, because they have the same variable with the same exponent. 3x squared and 4x squared are like terms. 5ab and 2ab. So these are just some examples of what I mean by a like term. They have to have the same variables with the same exponent. Here they both have an exponent of 2 and x squared, so they're the same.
I have a quick question.
Yes.
With the ones that can be distributed, does the constant term affect whether it's a like term or not?
It does. So like in these, if you distributed them, it would be 3x plus 3. The 3x and the 2x are the same, and the 3 and the 2 are the same. And we'll get to that in just a sec. I'm looking to see if I have a black marker. I don't like these colors. Let's see if it works. Okay, so. Oh yeah, there. Like terms. Are 3x and 4x squared like terms? No. How about 4a and 2ab? No. And this expression, which are like terms? The 9 and the -11 are like terms because they're both constants. 3x and 8x are like terms because they're both one variable of x. Very good. Now, if we wanted to combine the like terms, how we would rewrite this is 9 minus 11 is a negative 2. I'm trying not to put my back to each other.
It's okay.
Negative 3x plus 8x is a plus 5x. So I've just combined the like terms and simplified that expression. Let's try to do another one. What are my like terms in this expression?
6x and 7x.
Good. So I combine those two, and I get 13x. And the 4 has nothing to join with, so it's just still there hanging out. Okay? It's normal. Combine them. So look at another problem. Are those like terms? They are. Even though they're fractions, they're still like terms because they both have an exponent of 1x. But to combine them, what am I going to have to do? Get a common denominator of 15. So this becomes what over 15? 10. And what over 15 here? 12. So 10 minus 12 is a negative 2/15 x. So just because you have fractions or decimals doesn't change how you do it. Okay, you can still combine like terms. Here's an example with a decimal. These are like terms, correct? Yes, so I just have to do 3.72 minus 8.12. Well, we just learned from the test we took, when you're taking a bigger negative from a positive, you have to take the difference between them, and my answer will be positive or negative? Negative. Okay, so I'm taking the difference between them, and I'm making it negative. So negative 4.4a is combining those two terms. Any questions so far?
I do have one.
Okay.
Probably easy. Okay, over here, you did left to right first, but then in the middle 8x and 3x. Why didn't you go that way? You know what I mean? And that's a plus in the middle.
Well, I did 9 minus 11 and got negative 2.
Yeah.
And then I did a negative 3 plus 8.
Okay, it was a negative because of that?
Yes, whatever's in front of that term is its sign.
Okay.
Okay? Does that help?
Yes.
On the practice skills, can you do 11 and 12? 11 is 3x plus 6. And it says to combine terms when possible. I'm assuming you can't combine any of that.
Yes,
right?
it's already simplified.
That's it. Okay.
Yep. What was the other one?
So how would you write it? Do you just leave it as is?
You just say, yeah, you write it as is.
Okay.
It cannot be simplified.
And then
further.
12 is 4x plus 3y.
Same thing. Are these like terms?
No.
They're not, so it just stays 4x plus 3y. If you can't combine like terms, the answer or the simplified expression is just itself.
Had it been 4x times 3y, would it be 12xy?
Yes,
Okay.
that's right. If there's no addition or subtraction, then you would simply multiply.
Okay.
That's good questions.
Can I skip down and do some of the harder ones?
Well, let me finish this, and maybe I'm going to get to those.
Okay.
If I don't, then come back and ask me, okay?
Okay.
Because we're working our way up to harder. Okay, let's look at this one. We got to combine like terms. What would I combine? So it becomes 3x plus 10. Very good. Okay, let me call on somebody. How about Ryan? Can you simplify that for me?
12c plus 9c minus 12c.
Okay, you're combining these two, right?
Oh,
Mhm.
14c plus 7 minus
Very good. Okay, so the two like terms were these two. That's the only thing you could combine. and the other two just stay.
You have, does it matter when you put 7B and then combine?
It does not.
Okay.
And typically in math, you want to write them in alphabetical order, but they're both exactly the same.
Okay.
Because of the what property? What property says this is the same as this?
The associative?
Commutative.
Community, okay.
Remember, you can switch them around. So this means the same thing as this. It's just like the technical way people usually do it is write it in alphabetical order because it just looks cleaner. Good questions. Here's a long one for you. And if this is easy, don't worry, it's going to get harder. Raise your hand if you're willing to try it, or I will volunteer you. Okay, Zoe. Well, tell me what goes together first.
Negative 5x squared, negative 3x.
Good. So take that first, and what would that become?
Negative 8x.
Negative 8x squared. Okay, what else goes together?
7y.
Good. And that becomes?
5y.
Good. Positive 5y. And the last ones that go together are the? Good. Negative 5. Because that's negative. Yeah. Good. So if you take it one at a time, just find pairs that go together and write them. The trick is to go back and catch things that weren't paired up, because sometimes those do just by themselves. Okay. Very good. So that is a simplified expression. Okay, now let's talk about the distributive property. When we're doing things like combining these two terms to become 9x, what we're really using is the distributive property. Because if I pulled x out of both of these, that becomes 9, and I have 9x. So what we're doing is using the distributive property. Sometimes it will be written where there's still parentheses and the distributive property hasn't been used. So if you see parentheses in an expression or an equation, you have to get rid of the parentheses. How do I get rid of the parentheses? I use the distributive property. And we talked about this before. And the distributive property says that I'm going to multiply 6 by x and then 6 by the 2. So I have 6x plus 12. You use the sign here to decide if it's positive or negative. Let's look at another one. Here I'm going to have negative 4 times r giving me negative 4r. Negative 4 times 3 gives me a negative 12. The only way distributive property gets tricky is if you forget these signs. You forget to make this negative. Let's look at another one. This would be 8w minus 56. It's a negative 56. And the last one, negative 3r plus 27. So I gave you an example of different kinds of signs. If the negative's on the outside, if the negative's on the inside, or if the negative's both. So when you're doing it, just consider that sign with each term. Negative 3r, negative 3 times negative 9 becomes a positive 27. Any questions?
When writing like the negative 4r, you do negative 4r plus negative 12, or is that wrong?
That would be okay. If you want to write plus a negative 12, that's all right.
Okay.
A plus minus. Let's look if we have a fraction with the distributive property. Okay, we're going to do the same thing. It's just a fraction instead of a whole number. But negative 2/3 times 5. What does that become? What? Nope. Negative 10/3. t. Because this is like 5/1, Zoe, so you're going straight across, okay? It's kind of, if you pull it off to the side, what you're doing is negative 2/3 times 5t, and then you're doing negative 2/3 times 9. If it helps to write it out, maybe you want to do this step before skipping straight to the answer.
Wouldn't it be a plus sign after the 5t? Wouldn't you do it that way? Plus negative 2/3 times 9.
You could write it as a plus negative if you want, yes.
Okay.
Either way, it means the same thing.
Okay.
Yeah.
I got
That's okay.
confused.
That's okay. I can write it as plus negative. So, plus negative 2 times 9, negative 18 over 3. What does that give me? A 6. But a negative 6. Right. So a plus minus, or you could just minus 6. This or this mean the same thing. Okay. You understand how to distribute with the touch? All right, let's look at another one. Okay, why do I write my Z's with lines so big? Don't look too. Okay, this time I'm going to write out a long way what we're doing. We're saying negative 4 times 2x plus negative 4 times ey plus negative 4 times negative 5z. So that's what we're doing in our head. We're saying this times this, this times this, this times this.
Why is it plus negative 4?
I was doing that because someone asked me to write it that way. You can write just negative 4 if you want to.
Oh, I mean, I'm sorry, in negative 4 times negative 5 minus 4.
Because you haven't simplified it yet.
I haven't simplified. Negative 4 is times negative 5z.
Oh.
Oh, when I clean it up, this will become a positive. I'm just writing the steps of what you're doing in your head. You're just ahead of yourself. So this becomes negative 8x minus 12y plus 20z. Better? Some people, it's nice to see the steps of what we're doing. But if you can do this in your head straight from here to here, that's okay. And then at this point, you would combine like terms if you needed to, but there are no like terms. So that's simplified. All right. What if I had a problem with parentheses, but the 2 was on the right side of the parentheses instead of the left? Does that change anything? It doesn't change. It's not typically written that way, but you do the same thing. You're taking the 2 through both terms. So this would be 6a minus 8b. So just don't be thrown off if you see the 2 at the end of the parentheses instead of the beginning. Won't normally be that way, but it means the same thing. Okay. Sometimes students try to use the distributive property in places it can't be used. When you're using the distributive property, there has to be a plus or minus sign inside the parentheses, and I'll show you what I mean. If I did 4 times 2xy, or 4 times 2x plus y, what is the difference? Yeah, this one has the plus sign, so I'm actually distributing through 2 terms. Here I'm just multiplying 8xy. But here I'm doing 8x plus 4y. So they're very different results. You want to make sure when you're distributing a term, you're taking it through 2 terms only if there's plus or minus in between. Okay? How about this? Do I use the distributive property here?
Yeah.
No. This minus 4 does not mean a negative 4 is being multiplied by both terms. this is just minus 4 at the end of this. To take away the parentheses, it would just look like this. Whereas, if it had been written this way, negative 4 in parentheses, now I'm multiplying that negative 4 by both terms. Okay, there is a difference. If it's minus 4, it's just part of the expression. If it's in parentheses, you're multiplying the negative 4 through both terms. Okay? If I tell you the first step is to remove parentheses in a problem, what if I just have something written like this? Can I go ahead and just remove the parentheses? Yeah, because what's in front here? It's an imaginary 1. So you're distributing this imaginary 1 through both of them, and you can just simply take out the parentheses, and it means the same thing. However, if I have a negative in the front, what changes?
Negative 4 minus 3.
Yep, this negative has to be distributed through both terms. So you can't just simply drop the parentheses. You have to take this imaginary negative 1 through both terms. Okay, so big difference between here and here is the negative sign. When you drop the parentheses, you have to take the negative with you. Okay, last one like this. If I took away the parentheses, what does this become?
2x minus 3.
2x minus 3. That negative goes both terms. Okay.
Can I ask you a question?
Yes, ma'am. This is an EMS room, I think. Hopefully nobody needs it.
Just in case you pass out.
Okay, my one's in the
Can we take your turn?
Yeah. Okay, here's another problem. I lied. That wasn't the last problem. How do I drop the parentheses here? Looks like a negative 1. So when I drop the parentheses, it's negative 3x minus 7. Now in this problem, am I done after I drop the parentheses? No, what do I still have to do? Combine like terms. So this is 1 minus 3x. Or 3, yeah, negative 3x plus 1. Negative 3x plus 1 means the same thing.
Yeah.
Yep. Okay, I'm gonna call on somebody. Melinda? You're Melinda. Okay, Melinda, can you help me do this one?
Negative 4 fifths plus negative 2 thirds, or plus 2 thirds.
Very good. What can I combine?
X and 4 fifths, negative 4 fifths.
Okay, good. So if I combine those two, what do I have to do to combine them? I'm just rewriting them so they're next to each other. No, only when you multiply is it x squared. This is like what right here?
1.
A 1. If I'm adding a fraction to a number, I have to make this a common denominator. So this would be negative 4 fifths x plus, we'll make it 5 over 5, because that's the same as 1, right?
Yeah.
Okay, I lost somebody. If I'm adding an x to a negative 4 fifths, this is like a 1x. To add fractions, you have to have a common denominator. So another way to write 1 is 5 fifths. That way it matches my fraction. Okay. So when I put those together, I get 1/5 x plus 2/3. Does that make sense? Yes. And this came up on the test a couple places, but just for future reference, if a problem is given to you as a fraction, the answer has to be a fraction. If it's given to you as a decimal, the answer should be a decimal. So a lot of times students will turn fractions into decimals because they like working with them better and give me the answer in a decimal. But if it started out as a fraction, it has to end up as a fraction. Does that make sense? All right, let's try another problem. Stacy? Right here. Tell me your name. Brittany. Okay.
Okay, so this is the distribute the 1/4.
Good. Distribute the 1/4 comes first. And what do I get? No. 3.
What's the number B3?
3 what? Pretend like there's a 1 under here.
I'm doing math.
That's okay. What I'm doing is I'm saying 1/4 times 3x. If you just pulled that out, what would that be? But yeah, this is like a 1 under here, so you go straight across. 3x over 4. Does that make more sense?
Yeah.
Okay. So 3x over 4, and then 1/4 times -1 is -1/4. Very good. Okay, what are my like terms? This one and this one, so we have to get, okay, take one. 12, good. So this becomes 10/12, and this becomes
9.
9. Put those together and you have 19/12 x minus 1/4. And am I done?
No.
That's as far as I can go. How could I simplify it?
Well, 19 was.
Or you could write it as a mixed number too. So if you wanted to do 1 and 7/12, that would be okay. Okay, Shannon, can you help me with this one? Can you
Sure.
see it from over there?
Uh-huh.
Okay.
Yeah. Okay. 6 times 5x would be 30x
Good.
minus 18
Very good.
minus 2y
Good.
minus 8 minus,
Would it be minus 8
oh, no, plus 8.
plus 8?
Thank you.
Uh-huh.
Minus 8x.
Very good.
So now we combine terms.
Mm-hmm.
So 30x minus 8x is going to be 22x. Negative 18 plus 8 is going to be negative 10. And then minus 2y.
Very good. And that is simplified. Good. So we used the distributive property to get rid of the parentheses. We've combined like terms to simplify our problem. And that is simplifying the expressions. The end of section 2.1. Not too bad. And all this builds on itself to lead us up to solving equations eventually. Okay, this brings us to 2.2, which is going to be about the addition property. Of equality. Okay, first, what do you think a statement that shows two expressions are equal is called? Like if I have an expression on this side and an expression on that side, it's called an equation. Something like that. This side is equal to that side. When you have an equal sign, equations, we can solve for an answer. We can get an answer for x. A linear equation with one variable is written in this way, where a, b, and c are just numbers. Okay, so this is a linear equation with one variable. So the first we're going to learn is just where you have one variable to solve, just an x, just a y, just a z, not multiple variables. So something like 3x plus 2 equals 4. That would be a linear equation with one variable. Because equations all have a solution, you can plug them in to see if they're true. For example, I could say, is x equals 3 a solution? And what would you tell me? Yes, because you plug in 3 and it equals 7. Therefore, 3 is a solution to this equation. So sometimes in the homework you might see a problem, an equation like this, and it would just say, is x equals 3 a solution? All you have to do to find out is plug 3 in, like we did on the last test. 18 minus 5, 25, is this true? No. It is not true, so no, it is not a solution. Okay, when you have one a little more complicated, it still works the same way. Is negative 5/3 a solution to this? Well, the only way to find out is to plug it in everywhere you see x. Remember to plug it in parentheses. Okay, here, what do we do first? Before you even distribute, can you clean this up inside the parentheses? Of course you can. So negative 5/3 plus, what could I turn this into to have a like denominator? A what over 3? 9/3. And that becomes 4/3. Okay, so all I did is I'm cleaning up inside the parentheses by getting a common denominator. Multiply this through and you get 16/3. Does it equal 7 plus negative 5/3? Well, I'm not quite done because I don't know what this is. I have to get a common denominator. So this is 21/3 is the same thing as 7 minus 5/3. Is that 16/3? Yes, it is. So is this a solution? Yes. Okay.
How do you get that 9?
How did I get the what?
The negative 5/3.
This? Okay. Inside these parentheses, I wanted to add these together.
Oh.
And I can't add them together unless I have a common denominator. So I changed the 3 to 9/3. Okay, good question. So in these problems where they say is something a solution, all we're doing is plugging in and seeing if it's true. But most of the time in life, they don't give us the solution and we have to find it. So if they don't tell you what x is, you have to know how to solve for it. Okay. So to solve an equation means to find the solution. You do this by isolating the variable. Or what I call getting x by itself. Whatever you're solving for, whatever variable, you're wanting to get it to one side and get all your numbers to the other side. You're solving for the variable. to do this, we will use two properties. The addition property and the multiplication. And it's going to all be about balance. Whatever we do to one side, we have to do to the other side. So let me show you the addition property first. The addition property simply says, if A equals B, whatever I add to A, I also have to add to B to keep the equation balanced. Keep equation balanced. You can never add something to one side without adding it to the other. And when I say adding, I mean subtracting as well. So to keep something balanced in an equation, you have to do it to both sides. And here is an example. Okay, in this equation, my goal, remember, is to get x by itself, to find my solution. So to get x by itself, I want this -4 to come over to this other side. To move this -4, I do the opposite. I add 4, because then it becomes 0 and goes away. But whatever I do to one side, I have to do to the other side to keep the equation balanced. So now I have x by itself on the left and 1 on the right. So my solution is x equals 1. If I'm going to do a similar thing, but this time I have a +4, I want to get t by itself. So to get 4 to the other side, I subtract 4 from both sides because I'm keeping the equation balanced. That way I only have t on the left and 3 on the right. You guys probably remember this. Okay, this time I'm getting b by itself. How do I move the 10 to the other side? I subtract 10 so that it becomes 0, but if I subtract 10 there, I gotta subtract 10 here. So now I have -15 equals b. Okay, because this went away, put the -15 over here. Okay, how about Michelle? Michelle, what would I do in this problem? We add 3 to both sides. So I get -7 equals x. Now if I have decimals, works the same way. What I have to do to get r by itself, Roxy.
You would subtract 13.25 from both sides.
Subtract 13.25. So where it becomes tricky with decimals, if I have a -8.75 and I'm subtracting 13.25, what am I doing with these two numbers?
Well, since the first one's negative, you're adding it.
Good, because you're adding more negative. So this isn't really subtracting, you're adding these together and your answer will be negative. So -22 equals r. So you just have to be careful when you're adding or subtracting on the other side that you're following the rules of positive and negative numbers. Okay, so eventually if you have something like this, you're not going to write +5 + 5, you're just going to automatically know x equals 17. But until you get to that point where you can do this mentally, you need to write it down when you're ready. All right, so we talked about isolating the variable by using the addition property. The next is 2.3. We're going to talk about the multiplication property. And it works similarly. Because just like the addition property, what the multiplication property is going to say is if A equals B, whatever you multiply to A, you have to multiply to B. Now, jumping back a minute to addition, I said this worked for subtraction too. So it also is A minus C, B minus C. Whatever I subtract one side, I subtract from the other. So what do you think would be the same as multiplication? Division. So if I divide A by C, I have to divide B by C. Same thing, we're keeping it balanced. Whatever you do to one side, you have to do to the other side. Before we start some of these problems, I want to talk about reciprocals, because you're going to need them for this section. Reciprocals, what are they? What is the reciprocal of 2? It's the inverse, so it's 1 over 2. What is the reciprocal of negative 3/5? Negative 5/3. What's the reciprocal of negative 1? Negative 1. Because it's just 1 over 1. When you flip it, it's still 1.
Right.
Ooh, I got another one. What is the reciprocal of 0? 0. It's unusual. Because if you put 0 on the bottom of it. Alright, so we're going to use reciprocals for some of these problems. Because when you divide by a number, it's the same thing as multiplying by its reciprocal. If I divide by 3, isn't that same thing as saying 12 times 1/3? It is. So dividing by a number is the same thing as multiplying by its reciprocal. Same. Okay, first problem. Remember, our goal in solving equations is to always isolate the variable or do x by itself. I want x by itself, so I want to move this 4. If it's being multiplied, what do I have to do to move it? Divide. You always want to do the opposite of what it's doing. So I want to divide by 4, divide by 4, I end up with x equals 9/4. See, these cancel to become 1. Just like when we did the addition, we did whatever it took to become 0. In multiplication, we're doing whatever it takes to become 1. Because that's how we make it go away. Another way to look at this one, instead of dividing by 4, is to multiply by its reciprocal. It's just what I did over here. This is going to become more of an important tool when we get into more advanced problems. It's easier to multiply by the reciprocal than it would be to divide.
Are we going to be doing advanced problems on this call?
Yeah. So this means the same thing as that. So dividing by 4, multiplying by the reciprocal give you the same answer. Alright. I don't like that problem. Let's do this one. And here's an example of why a reciprocal might be better. Because to get x by itself, I have to divide by a half. But a better way of looking at dividing by a fraction might be, let's multiply both sides by the reciprocal. What's the reciprocal of a half? 2. So if I multiply both sides by 2, I get 30 equals 2 over 2 just becomes 1 x. Now, do you think that multiplying by the reciprocal is easier than dividing by a half? Let's look at this time. I want r by itself, but the 4 is on the bottom. How do I move the 4? Multiply by 4 over 1, or its reciprocal. Because it's being divided, I want to multiply. Remember, you want to do the opposite. So because I'm dividing, I'm going to multiply, because I want these to cancel to become 1. Whatever I do to one side, I have to do to the other side. So r is 28. Does that make sense? it. Here's where the reciprocal comes in very handy. I have a fraction that I need to move. So I can either divide both sides by 3/4, or I can multiply by what? By what?
4/3.
4/3. So if I multiply both sides by the reciprocal, these go away, they become 1. 9 times 4 over 3. So become what? 36 over 3 is 12. Another way to look at this is simplify before you multiply. 3 goes into 9 3 times. 3 times 4 is 12. Either way, you can either say 36 divided by 3 or simplify it first. I'm going to write down a couple on the board and I want you to try them on your own. No, you don't need a calculator.
Oh, come on.
No. No calculator. They're evil. 1, 2, 3. if you're not done, that's okay. We'll start with the group. Number 1, I'd like Carolyn to help me. Okay. What do I do with number 1?
Right now, next one.
Very good, 5 minutes. Okay. Number 2, how about Shireen?
Divide both sides by, I think it's -6, I can't see.
Yeah, it's -6, good.
And -4.
Would it be negative or positive?
Positive.
Positive 4, because a negative and a negative. Very good. Okay, number 3, Melody. Oh, okay. Yep, you divide both sides by what, do you think? 0.25. 0.25, and that's kind of not a fair one, it's a decimal. But 1.5 divided by 0.25 is 6. But yes, you divide both sides by that. Okay, number 4, Sarah.
Yes. I went about my own way on that.
Okay.
I changed 0.25 to a fraction. I still got 6.
Okay, that's okay.
As long as I get the right answers, it's how my brain works and does it.
That would be fine, yeah.
Okay.
As long as your answer, say it wasn't a nice 6, it was a decimal, or if it was fraction, you want to give the answer in a decimal.
When I did the other side, I left it as a decimal.
Okay. Which is okay. In this case, it worked out fine. But I just am worried for you, if you had a decimal problem and you're used to changing it to fractions, just make sure you put it back into a decimal.
Okay, well, on the other side, I didn't change the
Yeah.
1.5 to it.
Yeah, in this case, it was fine. It ended up 6, so it didn't matter. Just beware of that.
Okay.
Who did I say? Sarah? Sarah, can you help me with this one? You would. You could divide both sides by 5, 6. What's another option when you have a fraction? You multiply by the what? By the reciprocal. And it's the same thing. Dividing by 5, 6 is the same thing as multiplying by 6/5. All this does is it makes it easier to cancel these out, and then you can over here take 3 times 6, which is 18 over 5. Okay? Does that make sense to everybody? Those fractions screw people up a lot. So dividing both sides by 5, 6 is the same thing as multiplying by its reciprocal. Because if she did divide 3 by 5, 6, what would I have to do to that problem? 3 divided by 5, 6, I would have to rewrite it as multiplying, copy that flip, right? Multiplying by the reciprocal anyway. So you're just adding another step, and you eventually would have to do that. Okay. Number 5.
I multiplied 4 by -4.
Sure. You can either divide by -4 or multiply by -1/4, which I like that you did that because there's a fraction over here. That makes your life easier.
And then multiply by -1/4.
Mm-hmm. 32. Yes. Very good. So does everybody see what she did? You can divide both sides by -4. But again, if she said 5/8 divided by -4, because it's dividing fractions, eventually you would have had to multiply by the reciprocal anyway. Okay, number 6, Evelyn.
I have an idea how one does.
Okay, now let's walk through it. If I have to get x by itself and I want to move this -2/5 over here, I can either divide by -2/5 or do what?
Reciprocal, so 5
Good.
-5
Perfect. -5/2, those cancel. So I'm multiplying this by -5/2. And I don't like how that is. I'm going to write it like this. -7 times -5/2. That becomes what?
So it would be -35/2.
Yep. It's 35 over 2, but it would be negative.
Oh, because they're both negative, it'd be a
It'd be
positive.
5. It'd be 5 over 2. Very good. Okay, Does everybody kind of understand the multiplication property? So now we've learned the addition property, the multiplication property. We're going to put them together. And when you work equations, you're usually going to have to do both. Go ahead. Let me show you one problem we haven't talked about yet. What if I had negative x equals 7? Is that solved? No, because x by itself means it can't even be negative. So what do I have to do with that? Good. Divide both sides by a -1, because that's like an imaginary 1 there. So x becomes -7. I just don't want you to get to where x is by itself and have that negative sticking there. So the negative can't be in front of the x to be solved. Very good.
How can, I don't see how that works out, because wouldn't you be saying -7 equals 7?
Because, okay,
If you actually
if
add,
there's a negative imaginary 1 here and I'm dividing by -1, these
Uh-huh.
cancel to become positive 1.
okay,
7 divided by -1 is -7. So a negative, I don't know if I can another way to explain it. A negative x equals 7 is the same thing as x being -7.
I don't get it.
Let me try a different one. What if I had negative x equals -19? This time I have negatives on both sides. To get x by itself, I have to take the negative over here. So I'm dividing both sides by a -1, so x becomes positive 19. Basically, this negative flips that sign.
okay.
Okay?
I just can't see how you, the first one I don't see how you solve. When you say x equals 7,
Well, it
And then
wasn't
you-
x equals 7, it's negative x equals 7.
okay, negative x, oh, okay, so but -7 does not equal 7.
No, it doesn't, but you can't look at it as you're plugging something in for this. Your solution at the end, for instance, okay,
But how do you, I mean, I always use it as proof, okay? If the number that you get at the end, if you put it in and the math comes out right, then it's right.
sure.
But
let
I
me-
don't see how the math comes out right on
Okay,
that
let me
first
think
one.
of an equation for you where this would be the answer. I have to go backwards. Okay, so 4x equals 28. Okay, let's look at this problem, or this equation, okay? And I'm looking for a solution.
Okay,
If the first answer looked like this, negative x equals 7, how would I say is this a solution to this equation? What would I be plugging in?
well, that would make sense, but it doesn't make sense in the first one.
Well, I'm just trying to show you a different way to think about it, because what you're looking for is a solution.
Okay,
It's not saying this equals this. It's saying x equals this in this equation. Does that help?
So if you plug -7 into it, you're basically saying negative, parentheses, -7 equals 7. That's what it's saying. It's
Right.
negative, cancel it out.
You're saying if I put this back in here?
yeah,
Oh. Then if I said x is -7 and I put it back, it'd be -7 equals 7. Negative and a negative become a positive.
oh,
Thank you.
Okay,
I
thank
wasn't
you.
on
Thank
this-
you.
I wasn't following what she was asking me. Thank you, guys.
thank you very much.
Okay. Good. All right. But the bottom line is when you get a solution, you can't have the negative in front of the x. You got to move it to the other side, like here. Okay?
Mhm.
All right, good. So 2.4, my black marker. 2.4 puts all this together, the combining like terms, the using the distributive property, the addition property, the multiplication property. Everything we talked about today all comes together in 2.4. Hang in there, guys. It's almost done. Got about 30 more minutes. So now we're going to solve linear equations with a variable on only one side. Because eventually they'll be on both sides of the equation, but right now we're going to solve equations where the variable's only on one side. We're going to use addition and multiplication properties. Here are the steps you need to follow to solve equations. Step 1. Eliminate fractions and decimals on both sides, and I'll explain that in just a minute. 2. Use the distributive property to remove parentheses. 3. Combine like terms on both sides. These steps are what you're going to use throughout all of algebra to solve equations, okay? Step 4 is to use the addition property to isolate the variable. Basically get x by itself. Then you use the multiplication property. And last, you check your answer. Okay. It's important that we do the addition property before the multiplication property. All these steps will make more sense to you when we're working the problem. We're going to keep this up here and refer to it as we work each problem. I'll give you a second to get that down before I start. And that should be in your book as well, those steps. If you don't get it all written down.
Page 114.
114? Bless you. I may write some terminology different than the book, but it should be the same stuff. Okay. So let's look at this first example. Step 1, eliminate fractions and decimals. Don't have any in this problem, so I can skip that. Do I have any parentheses? No. So I'm back to number 3. Combine like terms. Nothing to combine. It's already simplified on both sides. Step 4, use the addition property to isolate the variable. That I can do. I'm trying to get x by itself. So what can I move with addition or subtraction to the other side? The 7. Add 7, add 7. I end up with 3x equals 18. Once all my addition and subtraction are gone, then I can move to step 5 and use the multiplication property. Now, what do I need to do to get x by itself?
Divide by 3.
Divide both sides by 3, and I get x equals 6. My last step is very important, especially on a test. Because you should never get a wrong answer, you can check it. I put 6 back in here. and I get 3 times 6 minus 7, does it equal 11? 18 minus 7, yes it does. So I did it right.
Do we have to check all of the problems?
You don't have to check any problems,
Okay.
but I suggest you do.
Well, I was just wondering if there was like specific ones you were gonna have to check.
No, unless I'll look at the test, I don't think it says show your work for checking. Okay, no. Just a good idea. Okay, next problem. Alright, same thing, we don't have to do number 1, number 2, or number 3. We're moving on to number 4. So what do I use the addition property on?
4.
The 4, I'm going to add 4 to both sides. And I get negative 3x left on this side and 2 on this side. Then I use my multiplication property by dividing both sides by negative 3. X is negative 2/3. My final step is to check. 3 is negative 2/3 minus 4, does it equal negative 2? 6 over 3 is a positive 2. Negative 2 is negative 2. Yes, it works. Okay. Number 1 I can skip, no fractions or decimals. Number 2 I can skip, no parentheses. But number 3, can I combine any like terms?
Yes.
I can. So I'm going to clean up the right side and turn it into 2x. Does everyone see where I did that? Okay, step 4, I'm going to use the addition property to move the 9 to the other side. So I get 6 equals 2x. Then I'm going to use the multiplication property to divide both sides by 2. And I get x equals 3. Am I going too fast? Okay. To check this, I plug 3 back in. 9 plus 9 minus 3, 18 minus 3, it does equal, so I'm good.
I have a question.
Yes, ma'am.
Is it gonna matter on the test if the 3 is overlapped because of 15 instead of 3? Or can we just do it?
No, you can say this too, is that what you're asking?
Yeah.
Yeah, that's fine.
You don't necessarily need it on the
I just did it that way because that's how it was lined up in this problem. But no, you can turn it around next time. Okay, they're going to get progressively harder. Okay, let's go through our steps. Step 1, no fractions, no decimals. Step 2, is there a parenthesis? Yes. So we have to do that first. I have to distribute to get rid of my parentheses. This becomes negative 7x. Negative 7 times 3 is a negative 21 equals 2. What's my next step? Combine like terms. This becomes negative 3x minus 21 is 2. My next step is my addition property. So I'm going to move 21 over here by adding it to both sides. And my last step, divide by
negative
3. Ooh, that's what I do. 23 over 3.
You don't have to simplify it. Like make it easier.
No, or negative 9, 8, 7. Okay, next problem. Okay, no fractions, no decimals, but I do have a parenthesis. How do I get rid of my parenthesis? Distribute. What am I distributing this time? A negative sign. It's like a negative 1. Imaginary 1 there. So I get negative 4x minus 3 equals 8. Be very sure with that negative there, you don't just drop the parentheses without changing the signs. Now I combine like terms and I get 1x minus 3 is 8. Use my addition property. X equals 11. Okay? If anybody has a question or I'm going too fast, you need to raise your hand and slow down. Okay, here comes our first problem with a decimal. Now, when I say remove decimals, or remove fractions,
Is that the division sign?
no. Minus?
Oh, okay.
You guys want me to write it bigger or
Sorry.
I think some people on this side of the room might have a hard time seeing it, so I'm going to rewrite it over here. Okay. Can you keep it in decimals? Yes, you could work with the decimals. But the recommended way for fractions and decimals is to remove them, so you're just working with whole numbers. How you remove decimals from a problem is you multiply the whole thing, both sides, by the largest decimal place value. What is this place value? Hundredths. So if I multiply everything by 100, look what happens. I get 100x. Now when you do this, you have to take the 100 through everything. 100x plus, this moves your decimal point twice to the right. So you get 236 minus, twice to the right, 5x equals 521. So now instead of decimals, you just have numbers, whole numbers, big numbers. Okay? So that would be step 1, remove the decimals. Step 2 would be to combine the like terms. The only like terms on this side is the 100 and the 5x. So that would be 95x plus 236 equals 521. Is everybody with me so far?
Yes.
Now I'm going to subtract 236, so I'm trying to get x by itself. So I get 95x on this side, and I get 285 on that side. Divide both sides by 95. X is 285 divided by 95. And here's the only problem. It said if you started in a decimal, you gotta end in a decimal. So I have to do 285 divided by 95. Okay? And that would go in
3 times.
3. Oh, perfect. How nice of them. 3. X is 3. So sometimes it looks hard, but it's not that bad.
And since it's a whole number, you don't have to worry about the decimal points.
Right. Right. But you wouldn't have wanted to leave it like that. That would not have been simplified. Now for decimals only, this doesn't apply to fractions, it's okay to not do this method. It would have been okay to keep them as decimals and just solve it this way. By combining like terms, I would have gotten 0.95x subtracted 2.36, 0.95x equals 2.85, then divided by 0.95, but then you'd still have to do this division, and you'd end up with 3. So for decimals, you can get rid of them this way, or keep them. But for fractions, you have to get rid of the fractions, and we'll do one of those problems. Okay? Here comes the fraction problem. Lots of size. 4 x plus 3 equals 2. Okay, first first step, it says, is to eliminate the fractions. How we eliminate fractions is we just multiply by the lowest common denominator. And in this case, there's only one fraction, so what is the lowest common denominator? 4. That means everything. Multiply by 4.
Why can't you do that? Once you get the same answer.
Yes, this problem, it would come out, they all would come out okay if you were to do fractions, but when you get long problems with like 5 and 6 fractions in them, it's just too complicated. That's why you just learn this way to get rid of them. And of course, when they show you the demonstration, they're picking a pretty simple problem, and I know you're like, well, it's just easy, multiply those, sides by 4.
But you're only looking for the 2, not the 3.
And then looking at the what?
Okay, so when you said multiply by least common denominator, you look at 1/4 and you look at 2. You don't look at x plus 2.
You just look at the 4th. That's the only fraction.
Oh, you compare to other functions.
Yeah, just the lowest common denominator.
Okay.
Yeah. Because this denominator is really 1. Does that make sense? Okay, so 4 times a 4th is just 1. That's how we eliminated it. It went away. I don't have to multiply the 4 by these terms because this is all one term together, right? But I do have to multiply it by the 2. So 4 times a 4th is just 1. So I'm left with x plus 3 equals 8.
I understand why you don't multiply.
Okay, let's say I distributed this 4 first. Okay, say I distributed those. If I multiplied each term by 4, look what happens, x plus 3. Okay? When something's being multiplied by something in parentheses, you only have to multiply it by the thing out front, because that's going to be taken through both terms.
Okay.
Does that make sense? I know that's kind of a hard thing to see. Okay, I can drop these parentheses because there's just a 1 up here. There's no negative, just a 1, so I can get rid of those parentheses. Then I use the addition property, and I'm left with x equals 5. Okay. Let's look at another fraction problem. This one will make more sense. Okay, when I say eliminate fractions, what is my lowest common denominator? 3. So I'm multiplying everything by 3. 3 times y over 3 becomes y. 3 times negative 4y becomes
Negative 12.
negative 12y. 11 times 3 is 33. So I've just made a more complicated problem with a fraction easy by making it linear. I got rid of the fractions. Now I can combine like terms and make that negative 11y. I don't, do you see this one?
I don't see how you got 11. I was thinking it was.
Okay.
Oh no. Okay, so if it was 1y minus, okay, 11. Got it.
That's okay. I see on faces when it's like, what? Okay. Now there's no addition to do, so I can skip 4. There's no addition or subtraction. I'm going to move right on to step 5 and use my multiplication property to get y by itself. So y is negative 3. Any questions? All right. We are going to do one more together, and then I'm going to have you try one on your own. Can everyone see this problem? Okay. Okay. We have to multiply the whole thing by the lowest common denominator. What is the lowest common denominator? When in doubt, you can multiply them all together. So that would be 35 times 6, which is 210. Okay. I know. It is very small. So I'm going to say 210 over 5. 210 divided by 5 is 42x minus. 210 times negative 2/7. Let me write this down here. 210 times negative 2/7. Remember, we can simplify before we multiply. This is an imaginary 1. I can take 7 in here 30 times. 30 and negative 2 is negative 60. It's easier to do the division first and then the multiplication, because by dividing first, I simplified it and then I multiplied. Okay, so I end up with negative 60x. Finally, I have 210 divided by 6 is 35. So I know it was ugly, but look at this mess of fractions, and now you have nice, easy numbers. And really, you would have had to get a common denominator here anyway if you had kept the fractions. You would have had to make a 35 and convert it. So either way, you're going to be dealing with getting it common terms. Now that I've got rid of the fractions, I can combine like terms, and this becomes negative 18x is 35. Divide both sides by negative 18, and x is just negative 35 over 18. And the hardest part was just figuring out what the lowest common denominator was. All right, here's the one I want you to try. Give that one a shot. Okay, are we done?
No.
Yes, no? So, okay, what is the LCD? 40. So what is the first term? 8x. Second term? Last term? 4. See how this makes this ugly thing so pretty? Negative 7x equals 4. Divide by negative 7. X is negative 4/7. Anybody have questions on that? How we did it? Are we good? Okay. Last thing. Here's some terms when you're doing your homework. When it says to evaluate an expression, it's asking you to find a numerical value given something. Like it will say x equals 6. So to evaluate an expression means to plug something in to get an answer. To simplify an expression just means combine like terms to get it to its simplest form. You're not looking for a number answer, you're looking for a simplified form. To solve an equation means to find the value or values of the variable. Okay? So they mean different things. Evaluate, simplify, and solve. Very good. Because sometimes you get expressions which do not have equal signs, and people try to solve them for something. There's nothing to solve because it doesn't have anything on the other side. So an expression is not solvable unless it gives you a variable, what it's equal to. All right. I am here for questions about your test or anything else if you want to come see me. Otherwise, free to go. Your homework is 2.1 through 2.4 in Math Lab.
Is that due Thursday?
Everything's due the day of the test, but I've suggested you caught up because you will probably have a quiz.
Yep.
Okay.
Is there a test Thursday too?
A test Thursday, no.
Okay.
There may be a pop quiz.
Okay.
Which,
Fair enough.
I'm going to shut
Okay, if
that.
I remember correctly in the syllabus, there's a way to drop my lowest grade, right?
If you attend, only miss 4 classes or less, then you can replace your lowest test score with your final. Now this is assuming your final is a better grade than the lowest test score.
Okay. This, by the way, this is the only math I ever used in the real world.
Yeah.
For algebra.
Solving correct.
Yeah.
No, it's usable.
10 years working in a pharmacy. That's the only. There
I
are 2
believe it.
equations and they're both related to this.
Like this. Well, that's good, and it's something you're familiar with.
Yeah? This I can do.
Goodness. But see, that first chapter you had to have to know how to solve some of these. You have to know how to do positive and negative integers. Those kinds of things. Oh, sugar, I forgot.
Just text me with your name.